Welcome to the session for Sustainable Modeling with ETAP. I am Nitin Chaudhary, working as an electrical engineer with ETAP, and today I'll be the presenter. The outline for today's session will be covering greenhouse gases' impact on climate, carbon emissions and their scope, how ETAP calculator helps to make your modeling sustainable. We will be covering the user interface and results interpretation with the demo. What is climate change? Climate change involves significant changes in the climate system over time periods ranging from decades to millions of years. The main driver that leads to climate change is the increase in greenhouse gases that cause global warming. When the sun's radiation enters the Earth's atmosphere, a fraction of it is trapped by the GHGs present in the atmosphere, and the rest is reflected back to the space. The trapped GHGs maintain the temperature of Earth's atmosphere, making our planet habitable and allowing for life to thrive. However, the problem is that human activity is altering this natural balance, giving rise to an enhanced greenhouse effect. Since industrialization, global greenhouse gas emissions have increased manifold. As per the latest data, the current carbon dioxide levels in the atmosphere have crossed the 400 parts per million mark. These man-made causes accelerate the process of global warming and thus climate change. The greenhouse gases can be categorized as direct emissions and indirect emissions. Direct emissions are the emissions from operations that are owned or controlled by the reporting company and fall under Scope 1. Indirect emissions can be subcategorized into Scope 2 and Scope 3. Scope 2 consists of emissions from the generation or purchase of acquired electricity, steam, heating, cooling, consumed by the reporting company. All remaining indirect emissions that occur in the value chain of the reporting company fall under Scope 3. As per the US EPA results in 2021, carbon dioxide is the most dominant greenhouse gas. The power industry plays an important role in these emissions. ETAP Carbon Calculator. ETAP has developed a carbon footprint calculator to help its users assess the amount of CO2 their electrical networks produce. Estimating carbon emissions footprint is of global concern as it correlates to global warming. Governments ashore and offshore are incentivizing the reduction of CO2 in generation plants, transmission grids, and electrical networks in general. These incentives are backed by the government mandates to help achieve a global reduction of CO2 emissions. The ETAP calculator focuses on Scope 2 emissions and produces CO2 assessments from energy usage. User interface. We will be using ETAP environment to illustrate the user interface. Let's open ETAP. Carbon calculator is available under Tools. Under the Inputs tab, we have Emission Factors section, which generates the network template based upon the emission factors. The users will be provided with the network template from the single line diagram that is currently open. Let's look at the network. It's a medium voltage network connected to the grid. The generator is present and is used to recharge batteries during peak hours, in the absence of solars. Batteries are needed throughout the night for safety and security equipment. Wind turbine, PVs, batteries are available in the network for clean energy. Utility emission factors are available based upon country and states. Let's generate the network template based upon the single line diagram. The network is generated. Let's open this file. Separate sheets are created for different types of elements. For example, utility, generator, WTG, PVs, transformers, circuit breakers. For sources like utility, generators, WTGs, and PVs, the user needs to enter the emission factors available from the manufacturer. Elements like circuit breaker considers the SF6 and its leakage factor for calculation. For simplicity, WTG and PV emission factors are considered negligible in this example. Let's close the file. The second section in the calculator runs a simulation. User can choose to run a new simulation using time domain load flow or use an existing simulation results from the file available in the project directory. For a new study, the user needs to create a time domain load flow study case for the calculation. What is time domain load flow? Time domain load flow is a program that calculates the bus voltages, branch power factors, currents, power flows for individual phases throughout the electrical power system on a time domain series. The source and the loads can change their input and output according to the profile or external data when time changing in the study case. Let's open the study case. For estimated results, user can choose to use a single load flow option in the TDLF study case. For more accurate results, user can choose time series load flow, which produces the results over the course of a specified time span. In this example, the study case is set up for a 1-week simulation with profiles for PV, WTG, and generators. The profiles are fed as an external data and is available in the project directory inside TDLF folder. The profiles helps to model a realistic scenario. Let's take a look at the generator profile. The profiles can be imported as an Excel file. For each element, a separate sheet needs to be provided. Let's open the generator profile here. Let's plot the real power. As we can see, based upon the profile, the generator will be running for few hours in a day during the peak time. The remaining time, the power from the generator will be zero. Let's run a TDLF study to see the impact of generator profile on the utility flow. Let's plot the results for utility. As we can see, during these peak hours, the utility flow has reduced from approximately 2.2 megawatts to 0.5 megawatts during the peak hours, and the generator is supplying locally to support charging the batteries. Now the TDLF results are verified. Let's run the carbon calculation. Let's click on the run button. Carbon calculator will call the time domain load flow engine to get the power flows, losses over the course of time, and the network topology. ETAP carbon calculator is not a static simulation estimating based upon constant power loss. It is utilizing the time domain load flow solution to estimate the network kilowatt hour consumption based upon operating values and the profile data. Results of the calculation are available in CSV file in the project folder. Let's take a look at the results in the output file. The results are being written in two CSV files, one for based upon the element type for the sources, loads, branches, and so on. The second result file plots the cumulative results of the sources in the network over a period of time. Users can visualize the results using plots in browser. The first chart represents a pie chart explaining the emission contribution by element types. The elements are being subdivided into three categories: sources, loads, and branches. To get the individual element data, a user can click on each section and we will have a bar chart explaining the emissions by each element. For example, the synchronous motor is generating 7.39 metric tons of carbon dioxide equivalent over a period of time. Similarly, for sources, the results can be plotted. The second chart shows the carbon emissions over time. From the ramp rate of the generator, we can see an adverse effect on the environment even running for a short period of time in a day. Grade also contributes to the emission, but at a lower rate. WTG is a clean source. Now we can conclude today's session. We utilized ETAP single line diagram to generate the network model. Emission factors can be customized in the network for each element. Running a study using time domain load flow over a course of specified time span allows to estimate the carbon footprint more accurately compared to the normal constant power loss. Importing source and load profiles help to replicate the real field scenario. Calculator can be used to design the network, selecting correct elements from multiple vendors based upon the emissions. Multiple plots and output files are generated to visualize the results. Thank you everyone for attending the session.